A small solid sphere falls freely from rest in air with an acceleration 10 meters per second square. So it's just falling under the acceleration of gravity, and in the time 5 seconds we find the distance fallen. Now we can use the safe approach, right? Starting with S, a sketch which is already given. Assign a sign convention. Okay, since the ball only falls, the sphere falls freely downwards, so we just choose this direction as positive. Okay, next we look at the variables that are given or unknown, right? The sphere falls freely from rest. Okay, so that tells us that this is the initial velocity. It's 0 meter per second. And it falls with acceleration 10 meters per second square, and this must be our acceleration due to gravity, 10 meter per second square downwards, positive since down is positive, and it's going to fall in a total time t of 5 seconds, 5 seconds here, and that left us with the unknown. Find the distance traveled, the displacement. Okay, so this displacement is also downward, so we expect a positive displacement in our calculation. Given these four variables, the equation of motion that has all these variables will be s equals ut plus half at squared, and we can really do our calculations by doing a substitution. Acceleration is 10, time is 5 seconds square. Okay, so half times 10 times 5 square. Using a calculator, you should get 125 meters positive. Okay, so we have chosen the equation of motion method. Instead of equation of motion, we could also use a graphical method instead. So if we use a graphical method, we'll use a VT graph, right? Velocity in meter per second, time in seconds, and this sphere falls really from rest, so starting from 0. It has a constant acceleration of 10 meters per second square, and therefore we have this straight line graph where the gradient represents this acceleration. Okay, now this graph has a gradient, so we can assign a suitable symbol for the final velocity, and this final velocity occurs after the time interval of 5 seconds as given by the question. Okay, so using calculation of gradient, this acceleration is actually equal, the gradient will be v minus 0 divided by the time of 5 seconds, and the acceleration is 10 meters per second. Okay, so that gives us the final velocity of 50 meter per second. Once we have this final velocity, we can proceed to find the distance fallen, which is represented by this area under the graph. Okay, so for this, we are using another feature of the graph. Area on the graph is equal to the distance required, right? And this distance required is d, and so d is equal to half base times height. Okay, 5 seconds times 50 meters per second, and that will give you us again 125 meters as the distance fallen in 5 seconds.